As we start lesson 47, we're going to be talking about graphs of equations that look like this. So I put these up and asked you to think about, based on what you already know on functions or on graphs, you know how to graph y equals 3 sine theta now. What happens with that minus 5 tacked on at the end, Molly? Yeah, can you tell me which way and how far? What do you guys think? Everybody point which way you think it's going to go. It's going to, when it's on the end, if it's a minus, it's going to go down 5 spaces. So this is going to shift it down 5. Now the second one is a little bit trickier when you look at it. Maybe if I wrote it y equals minus cosine theta and then a plus 7, would that mean the same thing, commutative property? You know how to graph y equals minus cosine theta. What about the plus 7 on the end? Everybody point which way that's going to go. So everybody's pointing up. So that's going to move it up 7. Now I want to point something out to you. We write it this way. When we are doing trig graphs, we write the shift first and not with the shift at the end. The reason for that is when we have the equation and we start doing the graph, we're going to need to start with what's the shift. That's going to be our starting point as we start drawing all of our lines, our guidelines, and our curves. We need to figure out what's that shift before we graph anything else. Also, it gets a little bit confusing. Sometimes students make mistakes when it's out here. They read it like this, as if it was a shift on the inside and changing the angle instead. And it just helps us not get as confused if we get in the habit of writing the vertical shift first when we write those equations. So let's see what we can do. In this lesson, we're going to be doing vertical shifts or vertical translations of our sine and cosine graphs, of our sinusoids. And we're also going to do a little bit with arctan at the very end and with all of the arc trig functions if we want to answer in radians instead of degrees. But mostly we'll talk about these shifts. So here I have one, and we know this is going to be the graph of 2 sine x, but we have that plus 3 at the beginning. So what does this plus 3 do for us from what we just talked about? It moves it up 3. Everything in the graph moves up 3. Particularly, we're used to the center line being the x-axis. That whole center line moves up 3. So now the center line is at positive 3. Now, if we didn't have the plus 3, what is it that the 2 would tell us in front of sine x? What is the 2 going to tell us, Olivia? So it's going to tell us that we go up and down 2. But since we're not starting at 0, we're not going to go up to 2 and down to negative 2. We're going to start at 3 and go up to, the amplitude is 2. So if we go up 2, we go up to 5. And if we go down 2, we go down to positive 1. None of those are the x-axis. That's why they're all dotted. Okay, now, if I just think about, if I am graphing this thing, it is a plus sine graph. Where does that mean I need to start? When I am in the middle, am I starting at the max min or the center line? Dylan? And going which way? So we're going to start at the center line and go up. So we still do our 4 tick marks each way. And then we draw in our pattern that we go up and then back to the center and then down to the min and back to the center. And over here we go this way. And then we can draw that in. Why is board shaking? I hope my graph isn't too bad there. And I look back at my original equation, and one of my variables is y, and the other one is x. Now, the center line is not the x-axis. The center line's for y equals 3. So I'm not going to put my x on the center line. This one, the numbers are such that very close to what I've done for my center max and min, I could add the x-axis in. X is for y is 0, so the x-axis needs to go for 0 would be just a little bit under the 1. I could, if I've got enough room, draw that axis and label it x. Now, if the min had been 100 and the max 104, you wouldn't be drawing the x-axis in, because if you did, your graph would be scrunched real teeny tiny in the top of your little box for drawing the graph. And the x-axis would be at the bottom, and most of the whole thing would be empty space, and you couldn't even see what the graph was doing, only when it's close enough to put it in. Now, the book does this when I don't want you to do it. If it were that one where you didn't have room to draw the x-axis, then you could do a little arrow that goes to the right and label it that the horizontal variable is x. The book does that too often. I want you to draw the axis in when it makes sense to draw it in. Does that make sense to everybody? Okay, the other thing we don't have on here, we haven't labeled our angles, and we always have to do that. This one could be either degrees or radians. I'm going to choose radians because I think we need practice, and I'm going to give you a choice of where you write it. You can either copy your tick marks nice and evenly on your x-axis and then write them along the x-axis. Or you may just write them along your center line. And so when I double check, I've got my curve, I've got the arrows on both ends, I've labeled both axes, and I've labeled numbers for the center, max, and min. Does that make sense for everybody? And that's what you always need to label on there, your center line, your max, your min. Those are with numbers. Dashed lines, if they are not one of the axes. And label the variables for the axes. So anytime you're drawing a sinusoid graph, that's something that you'll be doing. Does that make sense to everybody? So let's do a little bit of summary here. We'll do this. Okay, we'll do this first, and then we'll do the summary. So if we go the other way, if we start with the graph, can we come up with the equation? So we know that we need to come up with the center line and the max and the min. We need to figure out, is it a plus or minus sine or cosine graph? So let's start with that. Plus or minus sine or cosine, Gavin? Minus which? So minus sine because starts at the center line and goes down. So we know it's a minus sine graph. We know the max is 7 and the min is 1. But I think we need the center line and the amplitude, right? How am I going to get that? If it goes from 1 to 7, how am I going to figure out what the amplitude is, and how am I going to figure out what the center would be, Kane? And what does that tell me? If I take 7 minus 1 is 6 and divide that by 2, I get 3. Okay, so I could say that the amplitude is half of the distance between the max and min. So I could take the 7 minus 1 and divide that by 2 and get that my amplitude is 3. So I know this has to be a minus 3 sine theta graph. But I need to know how far I've shifted it, because that center line's not on the horizontal axis. How am I going to figure out how far I've shifted it? How can I figure out what the new center line is? Because that tells me what the x-axis or theta axis shifted to. Come on, you guys can answer this. Should see a bunch of hands up. Luke? So one way to do it, if I've got the amplitude first, I can say 1 plus 3 is 4 for my center line. And I always like to check, does it work the other way as well? 4 plus 3 is 7. Yep, I got it right smack in the middle. Were any of you able to just say, halfway between 1 and 7, I think that's 4? Some of them, when the numbers are small enough, yes, you can do that. The other thing that you can do is you can say that the center line is halfway between the min and the max. That means it's the average of the min and the max. So you can say the min plus the max divided by 2, and also get the center line that way. So now we put all of that together, and we say our equation for this is y equals, center line is now positive 4, so we shifted to a positive 4, minus, because it's a minus sign graph, 3 for the amplitude, sine theta. Can you see what's happening there? So here's your summary. Center line is halfway between the max and the min values. And I'm going to go ahead and give you the entire equation for every sinusoid that we will be doing. This is really a plus or minus, and this is really a sine or cosine. For right now, we are only doing y equals c plus or minus a times the sine or cosine, so I'll say trig, of either x or theta. Those other two variables, uppercase P and the Greek letter phi, we will deal with later on. For now, the center line is the average. It's halfway between min and max. So it's their average. And the amplitude is half the distance between the max and the min. So subtract them and divide by 2, and you have the amplitude to tell you how far above the center line you go and how far below the center line you go. Now, I bet you can predict for me in a future lesson when we talk about this plus or minus phi inside the parentheses. What kind of a change will that make on the graph? Same as it makes on any graph when you have plus or minus in there, Melina. It's going to shift it left or right. And have any of you in physics learned something else you could do to a sinusoid wave? So we've got our wave, we can shift it up and down now. We've just said in a future lesson, we'll learn to shift left and right. Any idea what else you could do to a wave, Dylan? You could spin it, but we're not going to get into polar coordinates on that stuff. But could we squish it together so that the peaks are closer together, or stretch it out farther? So we're going to change the frequency or the period, if you've heard any of those words. So that's what's coming in a future lesson, but just giving you that little bit of a preview now. That's going to be squishing and stretching it, to use my very precise mathematical vocabulary. And the number inside the parentheses will be the horizontal shift, also called the phase angle. So we'll be coming back to that, but this way you kind of have the overview as well as the specific part that we're dealing with is just y equals center line plus or minus amplitude times your trig function. Be sure you remember that the center line is the one that goes separate. The amplitude is the one that's multiplied by the trig function. So you guys give me an equation for this. We'll do two real quick ones of writing down the equations here. So look at this, figure out what your center line is, your amplitude, your variables, write down your equation, raise your hand. And I'll start with y equals. Maddie, have you figured out the center line? Well, would you please look up here and tell me what the center line is? You can probably do this without writing anything down. Do you see the min and the max? Okay, tell me what's halfway between the min and the max. Everybody good with, oh, if the min's 59 and the max is 61, I don't need to use a formula. I know 60 is what's right smack in the middle of those two. So we're going to do 60. And let's see, Davin, will this one be a plus or minus sine or cosine? Plus what? Sine or cosine? So it's going to be a plus cosine because it starts at the max. Variable is theta. What's my amplitude going to be on this one? Okay. So I can put a 1 in front of cosine or not. There's my equation. Thumbs up if that makes sense. Anybody with a question? Okay, one more before we go on to that arctan stuff. So same thing. What's your center line? What's your amplitude? Plus or minus sine or cosine? What are your variables? You may be able to just look at it and tell what the center line and the amplitude would be. If not, you've got the formulas for how you would be figuring that out. So we will start off with y equals. Taj, what's our center line? So everybody good with the center line is a 7? And you could either look at it and say, what's halfway between 5 and 9? Oh, I think it's 7. Or you could say, oh, what's halfway between 5 and 9? That's the average. 9 plus 5 is 14, divided by 2 is 7. Do we need plus or minus, sine or cosine, Sky? So we need a minus something cosine because it starts at the min. The other variable is x. And if the center line is 7, max and min are 5 and 9, then Olivia, what is the amplitude? So everybody good with how you can do those equations? All right, then moving on to our arc trig, our inverse trig functions. Very briefly today with that. When we've done arc sine, arc cosine, and arc tangent, we've restricted them to be between plus and minus 90 degrees or between 0 and 180 degrees. We can also restrict it to be radians. It's exactly the same quadrants, but if we write it in radians, arc sine, that's the one that we said had to be between negative 90 and positive 90. So if we do that with radians, it is simply between minus pi over 2 and pi over 2. And we previously restricted cosine to the top two quadrants between 0 and 180. So if we write that in radians instead of degrees, we're going from 0 to pi. And for our last one, arctan, we also restricted to the first and second quadrants. So also between plus and minus 90, which we now are going to say we can also call plus and minus pi over 2. But we can't actually be at the top and bottom of the unit circle because tangent is undefined there. So we don't have the or equal symbol. We use the curved parentheses for our interval notation for what that one is restricted to. And I just have a couple of special case examples once we have that written down here. So just a couple of very special problems I want to point out, and this is only for tangent, not for sine or cosine. And if we are taking arctan of tan, not something like sine of the arc cosine and those kinds of things. If you think about your unit circle, at both of those positions, isn't your tangent negative root 3? 180 degrees apart. If we wanted to take this one, isn't your tangent positive 1 for both of those angles, first and third quadrant? Because of that, we have something special that we can do when we're doing arctan of the tangent. Now, if I had arctan of the tangent, and this was something in Q1 or Q4, the quadrants I'm restricted to, my answer would simply be the same angle that I had in there. I wouldn't have to change anything. But if, like in this example, 120 degrees is not between negative 90 and positive 90, then I would be thinking, oh, the arctan of 120 I'm talking about here, or the tangent of 120 I'm talking about right here, that would be minus root 3. So now I want the arctan of negative root 3. Well, when I've restricted it, I can't go in quadrant 2. I know I have to come over here, and it is going to be my negative 60 degrees. It is exactly 180 degrees opposite. If this was 120, this was 60, and these two were vertical angles, so that's how I've got the negative 60 in there. Another similar one. Tangent of negative 120. That's going to put us down here where the tangent is the positive root 3. Well, I can't say my answer is negative 120 because all of my arctan answers have to be between negative and positive 90. So I simply go 180 degrees away from that and say that it would be 60 degrees. Now, where that comes into play is with the ones that we don't have memorized. What if I wanted the arctan of the tangent of, let's say, 130 degrees? I haven't memorized 130 degrees on my unit circle. So what I know is that 130 degrees would be right here, and that would be 50 degrees in there. So if I want arctan of that angle that has that tangent, I simply need to come 180 degrees away from that, measure that with a negative angle, vertical angles, that would be negative 50 degrees. So anybody with questions? Yes. In just a moment, but any questions on the ideas?